Hello viewers, myself Dr. KSR Radhika, working as Associate Professor in the Department of Computer Science and Engineering, SRKR Engineering College, Bhimavaram. So in this session, I am going to explain the topic round robin with interrupts architecture in the subject embedded systems. So in the previous session already we have seen round robin architecture. So in this session we are going to know about round robin with interrupts architecture. So the objectives of today's session are to know about round robin with interrupts architecture, to explore the differences between the round robin with interrupts and round robin architectures, and also to learn the advantages and disadvantages of this architecture. So first of all, we will see about the round robin with interrupts architecture. So this is somewhat a more sophisticated architecture than the round robin architecture. So whenever while discussing about the round robin architecture, we told that it is a very simple architecture. But in the case of round robin with interrupts architecture, so it is somewhat a little sophisticated architecture than the round robin architecture. So here mainly we have introduced the topic interrupts. That is, interrupts are being added to your architecture. So interrupt routines deals with very urgent needs of devices or hardware. So the interrupt routines. So here what the interrupt routines will do is they will set the flags to indicate the interrupt happened. So and also here the priorities are also given for the interrupt routines. So in addition to the round robin architecture, so here the interrupts have been added for the architecture. So suppose if you see here, so here also we will have all the devices similarly as in the round robin architecture. So in the round robin architecture also we have seen we have the devices from A to Z. So here what we are doing is, here we are writing the whatever functionality to be done for the device A. So that is being written as an ISR, that is interrupt service routine. So all the devices, for each and every device we are writing the interrupt service routines, and next whatever task code you have, you can write all those tasks. So here in the case of round robin architecture, so everything will be written simply as task. So but in the case of round robin with interrupts, so the hardware or devices, whenever they read some service, so they are being written as ISRs, that is interrupt service routines, interrupt routines. So whenever if you want a service, then that particular interrupt routine will set a flag, and then that particular ISR will be happened for you or executed for you. So and also whenever we are dealing with this interrupt service routines, so the interrupt service routines are being given some priorities also. So whichever is urgent, that particular device is given the highest priority, and so on like that. And here if you see in this diagram, the task code has been given the low priorities. Generally the ISRs, all that is all the interrupt routines are given high priority than your task code. So this is the main difference between the round robin and round robin with interrupts architectures. So first of all, we will see the how the main code can be given in the case of round robin with interrupts architecture. So here the main while loop polls the status of the interrupt flags and does any follow-up processing required by a set flag. Okay, so now we will see how this will be done in the pseudocode. So this is the pseudocode for round robin with interrupts architecture. So here if you see, so here so here we are showing it only for just for two devices. So here we are giving device A. So what we are doing is we are giving flags. So this is a flag for that is we are setting some flags. So this first initially for device A, F device A, the flag has been set to false. Similarly for F device B, it is also being set to false. So Boolean is the data type. Similarly, suppose if you have more number of devices means you can write how many number of devices you have, that many number of flags. So here in the case of so here it is shown only for 2 devices. So the remaining we are just giving it as some so on like that. So here we handle device A. It is written as an interrupt. So that's why void interrupt, and it has been written as an interrupt. So this here what it is doing, it is just taking care of the IO device A, and here what it is doing, it is setting the F device A flag to true. So that means what? Suppose if it is set to true means it indicates that now the device A requires the service. So if it is set to true means it indicates that the device A requires the service. So similarly, for device B also you should write the interrupt routine in the same way. So void interrupt, we handle device B. So here take care of IO device B, and here what we are doing? We are setting the F device B flag to true. So whichever flag is true, that particular device requires the service. It indicates that that particular device requires the service. So in the main function, so we are writing the while loop. In the while loop, what we are doing? We are giving if F device A. So suppose if it is true, then it will come to, so if it is true, then only it will come here. So once if it is true means, that means it requires some service. That is device A requires some service. So if it is true, then it will come to this and then what we are doing? So now we are providing the service. So that's why later it will later when again if it wants service means again it will be set true in this interrupt routine. So that's why what we are doing. So once the service is being handled here, so that's why what we are doing, we are again setting the flag as false. So then what we are doing, we are handling the data to or from the IO device. So that whatever the device A want, that particular service has been done, and also the flag has been set to false. Similarly, for device B, if F device B, if it is true, then it will come here. So after coming here, then what it will do? It will set the flag to false, and also it will handle the service that is required by the device B. So like this. So how many number of devices you have, that many number of conditions you can write, and you can provide the code for your application. So this is the pseudo code for round robin with interrupts architecture. So the main advantages of round robin with interrupts architecture. The first one is, so it requires it has more control over priorities. Suppose if you see, already I told that here we are writing we are writing the service for the different devices as interrupt routines. So and also for the interrupt routines, the priorities has been given as high than the normal task code. So that's why here we have more control over the priorities. So the device routines can be served in any order. So you can provide the order. So in whichever order you want. Suppose if you consider, suppose if you have A, B, C, three devices. So out of these 3 devices, suppose if C is of somewhat an important task has to be done. So then what we can do? We can give high priority to that particular device routine. So that is the C will be given as the highest priority. So then that will be executed first. And also one more point is processor interrupt priority settings can be used. So you can also give processor interrupt priority settings. And also the interrupt routines get good response. So that means, so whenever you are using the interrupt routines, so suppose if the task code is being executing also, so if the currently it is executing a task code, once an interrupt has been occurred, so it will suspend that particular task code and the service will be given for the interrupt routine. So like that we will have good response. So by getting the good response, we can say that the latency is low. So the main here, that means whenever we are getting this task code being executed, so the main loop can be suspended and directly you can go to the interrupt routine. So interrupt routines, so whenever you are writing the interrupt routines, so generally whenever we are writing the interrupt routines, so we should take care that they are short and very, very short, so that they will be executed very fast. And also the interrupt code inherently has high priority than the task code. So already at the beginning I told that the interrupt routines have high priority than the task code. So that's why even though a task code is being executed also, once an interrupt has been occurred, so the priority will be given for the interrupt routine. So these are the advantages of round robin with architectures. And disadvantages, this is somewhat more complicated than the round robin. So because here we have also added the interrupts and also the interrupt routines and also the priorities. So that's why here it is somewhat complicated than round robin. So one more problem here we have is context problems. So here we can get the context problems. That is, saving and restoring the context inside the interrupt routines becomes necessary when number of registers or resources is small. So here whenever it is shifting from, it is switching from one routine to another routine. So that is between the interrupt routines also. Suppose if it is executing a low priority interrupt, so at that time, suppose if it gets a high priority routine, so then also there need it needs some context switching. So that's why suppose if the registers or resources are small enough, then so the context switching may be somewhat a major problem. And also whenever we have these context switchings between the tasks or interrupt routines or all these things, so then again we have definitely the shared data problem, because the data may be shared between the different routines. So if it is being shared, then definitely the shared data problem comes into picture. So because of that one, debugging also becomes somewhat more complicated. So these are the disadvantages of round robin with interrupts architecture. So now we will see a simple example, that is a simple bridge. So a simple communication bridge which passes the data to and fro between two communication links. Okay, so this is a simple communication bridge, and here it passes data between two ports. It forwards the data traffic received on the first port to the second port and also the vice versa. So here we also assume that the bridge encrypts the data at one port and decrypts it at the other port. So if you see in this diagram, so you can see, so you can forward the data. So this is a communication link A and this is communication link B. So suppose if you get the data at B, so then it will be forwarded. So that is the data will be forwarded from B to A. So that means here it will be encrypted and here it will be decrypted. So and suppose if you have a data on communication link A, so then the data is forwarded from A to B like this. Okay, so this is a simple bridge application. So here what would happen is, so first of all, suppose if you receive a character, so these are the main things that will happen in a simple bridge. So that means suppose if you receive a character at one of the bridge links, causes an interrupt that must be served before the next character arrives. So that is, for example, so if you a character is received at this link, so then what happens? Immediately an interrupt occurs. So an interrupt occurs, and this particular character must be serviced before the next character arrives at this link. So this is one thing that has to be done. So once the link will be suppose after receiving the character, the link will be busy while sending the character. So the link will be busy while sending this character. So after that, it will interrupt the microprocessor to indicate it is ready for the next character. So suppose if the character has been sent to the link B, so then again it will interrupt the microprocessor to indicate that it is ready for the next character. So then what happens again? So that means what, here we are writing the read routine, write routine. So suppose if you are getting a data from B to A, so at that time this is ready to read the data. Suppose if it gets the data, means it is ready to write the data. That is, it is writing the data to link B. So that means you will have the read routine and also the write routine. And also it should also check continuously the queues. So whether there is any character to be written or read, all those things. So, and also here you should also have the encryption and decryption. Suppose if you receive a character here, so you should write the encryption routine, and also here you have to send the decryption routine also. So the encryption and decryption routine are also compulsory. So transmitting and receiving the characters, so they are being given as the interrupt service routine. So shared data sections are made here. You should also take care of the shared data. That is, the shared data sections are to be made as atomic, and the read and write routines have high priority than the encryption and decryption routines, because the read and write routines, so they will interrupt immediately receiving a character onto the link. So that's why they are having high priority than the encryption and the decryption routines. So this is how a simple bridge will work. This is how it will work whenever it receives a character for writing or reading. So for this one, we need to write the main routines. That is, one is read routine and write routine, and also you should also write V encrypt and V decrypt routines for the V encrypt and V decrypt routines for encryption and decryption, and also and also for the process data to, that is, queue data to link A and queue data to link B. And also another routines are F link A ready to send and F link B ready to send routines for sending the characters. So all these routines must be written for this simple bridge. And now we will see how we can write the pseudocode for this simple bridge. So this is the pseudocode for the simple bridge. So here if you see, so first of all we are having a queue of size 100. So this is the queue structure with the type def struct. So here we are giving the queue, that is char chq of queue size, that is 100, and here we are having the head and the tail pointers. So queue is the queue that is being maintained for our simple bridge. So, and these are the different routines, that is queue data from link A, queue data from link B. So this is a two-way communication link. So that's why we'll have both from link A and link B. Similarly, this is from link A from link B. Similarly, you also have queue data to link A to link B. So for reading and for writing, both. So for both we have two routines, and also two routines, and also here we are having two boolean flags for both, that is F link A ready to send. So that is, once a character is ready to send, it should interrupt and it should interrupt and then it should send the character. Similarly, F link B ready to send is another boolean flag for the link B. So here we sent character on link A, it is being written as interrupt, and also we sent character on link B is also written as an interrupt, and these two are for sending the characters and these two are for receiving the characters. So all these four are being written as all these four are being written as interrupt routines. So we send character on link A. So suppose if you want to send a character from link A, then what you have to do? You have to first of all set this flag to true. That is F link A ready to send flag to true. And then similarly, suppose if you want to send a character on link B. So then what you have to do? You have to set F link B ready to send flag to true. So then that particular service will be, that particular routine will be executed. That is for link B and this is for link A. Similarly, suppose if you get a character. So if you get a character on link A, we got character on link A. So that is, so you got a character on link A. So then what you have to do? You have to read that character. So CH is equal to read character from communication link A. So you have read that character and then what you have to do? You have to add it to the queue. That is VQ add. So you are adding that particular CH character onto the queue. So similarly, this is the interrupt routine for we got character on link B. So the code will be same because here this is for link A and this is for link B. So here you are reading the character from communication. This is for B. So that's why you will have link B. And also here you will have the pointer for that is link B. So that is data from link B. So you have to give that particular pointer. So we Q add and that particular data is also being added to the queue. So these are the interrupt routines. And in the main function, first of all, you are initializing all these different queues. You are initializing all these different queues. That is data from link A, data from link B, data to link A, data to link B. So all these queues are being first of all initialized. And then what we have to do? First of all, we should enable the interrupts. We should enable the interrupts because here all the tasks are being done by the with the help of your interrupts. So first of all, we are enabling the interrupts. So in order to enable the interrupts, we are using the function enable off. So in the continuous while loop, first we are doing what we are doing. We are calling the functions, that is the task code functions, we encrypt off, we decrypt off. Okay, and then what we are doing, if F link A ready to send, that means, so suppose if this flag is true and there is some character on your queue, that is FQ has data. So that means what? There is some character on the queue. So then what it will do? It has to send that character. So then what it is doing? First of all, you are reading that character onto the CH and then again you are disabling the interrupts. So why we are disabling the interrupts is, so while this is sending the data, to link A, so only this must be done. So that's why at that time, no other interrupt must be occur. So that's why what we are doing, we are disabling the interrupts and then send the CH, that is this particular character to link A. So once sending the character is over, then again your flag is being set to false. That is F link A ready to send. Again it is being set to false. Suppose if again next character arrives, means again this particular flag will be made it as true in that particular interrupt routine. Okay. So once the character has been sent, so the character has been sent to link A and also the flag has been set to false, and then again we are enabling the interrupts. So now again if any interrupts occurs, means again the control will go to that particular interrupt. So while doing this task, so then the why we are disabling the interrupts is, so because this task must be completed, then only, that is the sending of the character must be over here, then only you should interrupt for another interrupt. Okay, so that is over. So once next, similarly you should also check for the link B. So if link B ready to send flag is true and there is some data, FQ has data on link, that is Q data to link B. So to link B. So then what it is doing? Again it is reading the character from the queue, that is CHQ get data. So it is reading the character to CH variable and here again it is disabling the interrupts and then it is sending to link B. And again, similarly as how you have written for link A, the same way, but here you are doing everything for link B. So again, the flag has been set to false, and finally you are enabling the again you are enabling this uh, interrupts. So this is what is written in the main function. So in the case of this v encrypt and v decrypt functions, what they are doing, so here uh, continuously while there are characters on from port A. So what it has to do? It has to encrypt the data. So that's why here we are checking in a loop. So that is when data from link A, there is some data. FQ has some data where from link A. So if it has some data, encrypt them and put them onto the queue for port B. So you should first encrypt it and then you should put it onto the port B. That is, so first of all, you are getting the data and then you are doing some encryption. So you are using some encryption algorithm to encrypt this particular data, and then particular encrypted data is being saved here, and this particular encrypted data is being written to where? Q for the port B. So we Q add to which queue? Q data to link B. So this particular encrypted data is being added to link B. So the same process here it will be done in reverse, that is decryption. So for decryption again the process is same, but here it will be encrypted, but here it will be decrypted. So while FQ has data from link B, so then what we are doing? We are decrypting them and then putting them onto the queue for port A. So that is you are getting the data, that is whatever data you will get here, you will get the encrypted data. So now that encrypted data using some decryption algorithm, you will decrypt it and you will get the original data. So suppose if you see here, this is CH clear. Similarly, this is CH clear. So this CH this is encrypted data and this is encrypted data. So now you got the original data. So that original data is again written onto the, that is added onto the queue, that is queue data to link A. So this is the process of the decryption algorithm. So this is how you will this is how you can write the pseudo code for the simple bridge, that is used as a simple communication bridge. So in this session we have discussed about the round robin with interrupts architecture, and also we have seen the difference between the round robin with interrupts and round robin architectures, and also we have discussed about the advantages and disadvantages of the round robin with interrupts architecture. So if you like my video, please like, share and subscribe to our channel. Thank you.